This past week, I attended the Association for Diagnostics and Laboratory Medicine 2023 Annual Scientific Meeting and Clinical Lab Expo. And this was a 5-day deep dive into the most disruptive technology in the diagnostic space and the future of laboratories. So the key theme that was jumping out from the first day is that many of these previously futuristic technologies that we made movies about, well, they're finally here. We have AI, machine learning, automation, miniaturization, drone delivery, etc. And I'm not kidding when I say that there were some technologies that were really making my jaw drop and my heart skip an excited little beat because the future feels like it has finally arrived. And I had so much fun making the last video about my experience at Health that I decided to make another video about this latest conference. But this time I'm sharing the top 8 most disruptive technologies I came across at the conference. And it was hard to narrow it down. It was actually supposed to be top 5, but then it became 8 because there were so many cool things. First, I want to make a disclaimer. I'm not a lab expert. I've never even stepped into a lab in a professional capacity. I'd say about 25% of my experience in this space comes from my background as a senior AI strategy consultant at Deloitte, where I help our life sciences and healthcare clients understand the art of what's possible with AI, and I help them navigate how to integrate AI and advanced technology into how they operate. And the other 75% of my experience comes from my curiosity to understand my body and optimize my health and fitness on a personal level. So basically my patient experience. Over this past year, I have completed so many different diagnostic tests all over the place, from labs to doctors' offices to walk-in clinics to at-home tests, where you would have found me trying my best to follow instructions for all kinds of different blood, urine, saliva, and stool tests.
All right, it is 7 a.m. about, and I'm actually getting my blood drawn here in my own room.
I've done different lab tests on the same day around the same time to compare the results and see if I could really trust the information I was getting. I relied on the tests and collection practices of many different companies: Quest, LabCorp, Genova Diagnostics, Biome, Walk-in Labs, Vibrant America, Knowing Labs, and so many more other companies. And I brought my results to my primary care provider and to specialists and found out in many cases, I knew more about the biomarkers than they did. And the sad fact is that what I knew barely scratched the surface. So I wanted to know more. And so I started taking organic chemistry and biochemistry courses. I was going through all of the various support guides, and I built a database of all of my results so I could compare my biomarkers over time and in connection to each other. While I may be a novice when it comes to what actually goes on in the lab, I do feel like I've had quite a bit of personal experience trying to navigate and understand the diagnostic process itself. All right, so let's get into it. And I'm going to start with 2 companies operating in the space that gets me the most excited, which is point of care and potentially in the future at home, comprehensive lab tests with a very small sample of blood. So the first shout out is going to Vital and Truvian, the 2 companies operating in the space that I ran into at the conference. And what they allow you to do, because they both have somewhat similar models, is get a complete blood count with differential, a comprehensive metabolic panel, a lipid panel, and various immunoassays, which can do things like detect inflammation and nutrients deficiencies or abnormalities. And they allow you to do this all at the point of care, as opposed to sending out a sample to the lab. The Vital Home, as far as I'm aware, this would be the first solution that is creating a device to sell directly to consumers that can provide comprehensive lab results in minutes for at-home use. So what's the catch? Well, it's not commercially ready yet, and it probably won't be for at least a few years. The company is focused on a point of care device that providers would use in their clinics. And, not only is the product itself still in development, but there's also a lot of regulatory, legal, and ethical hoops that they're going to have to jump through. So, as straightforward as it sounds, actually giving consumers access to this kind of health data without a doctor in between opens a really big can of worms. What happens if a consumer self-diagnoses, takes treatment into their own hands, and ends up being wrong? who's responsible, and how do we ensure that consumers are going to be responsible with this kind of data? So as exciting as it is that this technology is on the way, we as a society may not be quite ready. But I got to meet Vital's entire founding team and learn more about the incredible work they're doing. And a couple of things I noticed when talking to them is they're really excited to tackle this challenge. And they believe it starts with 1, education and awareness, and 2, really great product design. So figuring out a way to ensure that what comes out of the at-home device aids consumers on their health journey, but doesn't lead them to unsafe or unsound treatment. And one of the things that was the most exciting part of all this to me was the fact that their team is trying to offer a device like this in the $500 to $1,000 range. Just for reference, every time I get these tests done through Quest or LabCorp, uncovered, it's maybe like $200 to $300. And I've been doing these every 6 months. So to have a machine where I could do this as often as I wanted for $500 to $1,000, this would change the game. So while I wait for this at-home device to come out, the reality is we have 2 companies here with point-of-care devices that provide clinical-grade routine blood work results in a matter of minutes, which means that the current doctor's visit is about to go through a dramatic glow-up. So currently, you go to the doctor, you talk about your symptoms, the doctor orders the blood work they think is appropriate, you go home, you wait to hear back. You usually hear back over the phone or email if you hear back at all. In many cases, I never hear back from my doctor. But if your doctor does give some explanation of the results, they're often somewhat distracted. You're no longer in front of them. In the majority of cases, they say everything looks normal. They give some basic recommendations because there's another patient coming in soon and they only have a few minutes. Well, those days are coming to an end because this is the future state process that I now see. You go to the doctor's office, and as soon as you get there, you complete some routine blood work. You go into your doctor's visits, and they already have your blood work. They listen to your symptoms, and then they combine your qualitative description with your actual blood work to guide the diagnoses, treatments, and next best steps. So then they can explain any abnormalities to you face-to-face and actually have time to answer your questions and truly be a guide to your health. Wow. So, and that's really only the short-term future because this technology is already here. I have a lot of thoughts on the more long-term future, but I will save those for another time because I want to get to disruptive technology number 2. Okay, so at the conference, Pattern Bioscience won the 2023 Disruptive Technology Award for its groundbreaking single-cell microbiology technology. Pattern has essentially designed a novel culture-free test that quickly identifies infection-causing pathogens and assesses their susceptibility to antibiotics within 4 hours. Why is this so significant? Okay, so let's walk through the current state process. When you get a serious bacterial infection, the treatment is usually the right antibiotic as soon as possible. But it takes a while to figure out the right antibiotic with today's current tests available. So current tests identify the pathogenic bacteria and the best antibiotic for that bacteria around 2 to 4 days because they rely on growing a bacterial culture, which takes time. But given the time-sensitive nature of the situation, doctors usually have to start a patient on some sort of antibiotic right away before lab results reveal the best treatment path. This results in antibiotic overuse and has led to a rise in drug resistance, which a lot of us are probably familiar with. And as Pattern highlights in their literature, more than 700,000 people die each year from drug-resistant bacterial infections, which is a figure that could grow quite large. They're estimating 10 million deaths by 2050. What Pattern does differently is their test uses a fusion of single-cell analysis and AI to directly evaluate individual bacterial cells' responses to antibiotics, which eliminates the need to grow a culture. That's the time-consuming part. With this information, the healthcare team can then make an informed decision about antimicrobial therapy. So unlike polymerase chain reaction, which is better known as PCR, thanks to COVID, or sequence-based methods that evaluate the genetic targets linked to resistance, Patterns technology is measuring the response of the bacterial cell to antibiotics and thereby determining exactly which agents can be employed for therapy. So this process is similar to the standard of care culture methods, just faster. So as of now, patterns technology is the first and only emerging technology capable of comprehensively diagnosing pneumonia directly from a clinical specimen. And so this led to the FDA granting the company's Pneumonia ID/AST panel a breakthrough device designation. And while the company has just initially focused on pneumonia, this can easily expand to a wide array of infection-related diseases. So I got the opportunity to talk to the founder after watching her amazing presentation, and it appears this technology is still a ways out from being hospital ready. But what does it mean when it is ready? If you have an infection or a suspected infection, you can basically take a test as soon as you arrive at the hospital, potentially even while you're in the waiting room. And then when you see the doctor in the next few hours, you'll be able to confirm a diagnosis. And if it is an infection, know which antibiotic will work best. So this means you can start the right treatment very quickly and not waste any time in trial and error antibiotics while a culture is growing. So this is very exciting. And you may be noticing a theme here of acceleration. I think that was one of the biggest things that I was taking away at the conference is technology is accelerating the pace at which we can diagnose and treat. And in a lot of life and death situations or just disease in general, time is of the essence. So these are very exciting innovations. Okay, we've now made it to disruptive technology number 3. And this is the mass spectrometry pen for essentially kind of like use in cancer treatment. So let me back up a little bit. Advances in mass spectrometry seem to be a key theme at the conference. There are a number of different companies working on leveraging mass spectrometry and AI for a variety of use cases. But the one that stood out to me was MS Pen Technologies. So first, just a quick primer on mass spectrometry. It's an analytical tool that's very useful for measuring the mass to charge ratio of one or more molecules present in a sample. These measurements can often be used to calculate the exact molecular weight of the sample components as well, and then identify unknown compounds via the molecular weight determination. So this technology is typically what's behind things like drug testing, food contamination detection, carbon dating, etc. So essentially what the MS Pen is a simple to use diagnostic device based around mass spectrometry technology that can provide real-time molecular information at the point of care to guide clinical care decisions. So let's break that down and talk a little bit about the key use case that the company is targeting, which is the ability for surgeons to detect whether tumor tissue is present in cancer removal surgeries. For example, if a woman is undergoing a procedure to remove cancerous cells from her breast tissue, as is the case with breast cancer, a surgeon can use the MS Pen around the area to ensure all traces of the tumor are gone, which can eliminate additional surgeries needed. So in the current state, the removed mass is sent to a lab where tests are run to assess whether the entire tumor was indeed removed. And the average wait time for traditional histopathology, as it's called, is 40 minutes or longer. If traces of cancerous tissue remain, which does happen frequently, then the patient must undergo an additional surgery at a later time because 40 minutes is too long for everyone to just be hanging around. So MS Pen's incredible technology basically provides this same information, but at the point of care in seconds, which not only eliminates unnecessary procedures and the associated financial burden of that, but it also cuts down procedure time, it decreases prolonged anesthesia use, and it's lowering the risk of infection. So this is really exciting stuff to be able to do surgeries and do it right the first time. So the next disruptive technology that really caught my eye was Vision AI and what I saw different companies doing with that. So there were a number of different companies I saw working in this space: Pixel, Cognance, Sight, Scopio, Sysmex, TensorID, to name a few. There's probably more. At Deloitte, I was actually part of the team that was standing up our Vision AI practice. So I've spent quite a bit of time in this space understanding the art of what's possible. The lab and a lot of the data that it produces is so visual, which actually makes it the perfect playground for Vision AI use cases. So you have the basics that affect the logistical flow of the labs, everything from quality control to ensure labels, barcodes, and caps are on and in the right place, detection of liquid volume based on the fill line, knowing real-time inventory levels and the exact location of every item in the lab, real-time alerts when instrumentation, maintenance, or replacement is needed, as well as if fluid needs to be filled. And the crazy thing is that before Vision AI, there were lab personnel that performed these basic tasks, which are manual, tedious, time-consuming, not very fun. But then you have the more exciting clinical use cases wherein you actually use Vision AI to improve diagnoses and treatment. So a really popular term here is digital microscopy, i.e. cell recognition powered by AI. So basically anything that you could do under the microscope, which is essentially human eyes looking at things, great use case for AI. So we can now use AI to identify anything abnormal and high quality images of cells. For example, you could detect parasites that are in red blood cells. Scopio has an application for full field bone marrow aspirate detection, wherein the AI flags and prioritizes the important cells for review. And it can do this in about 25 minutes, which vastly exceeds the time it would take for a manual review, which the person from the vendor I talked to said it usually takes someone about an hour or more to review. And the cool thing is AI will probably be able to do this faster and faster over time. Whereas humans, we kind of have a limit as to how fast we can really do something. We can also use Vision AI to analyze abnormalities in graphs or other visual representations of our data, right? So when we get data from mass spectrometry, MRIs, etc., we can use AI to help us flag those abnormalities. And both Pixel and Sight have developed a portable point of care device that offers a complete blood count with 5-part differential in just minutes that is accurate and specific according to them. So, like I said before, essentially Vision AI can be used to assess anything that was previously looked at through a microscope. And it can do it a lot faster, at a very detailed level, and with higher accuracy than a trained person already. And while the specs vary by company, on a general level, we're not just talking a little faster or a little more detailed. We're talking about a very significant, impactful difference in performance. And there's another huge benefit that's lurking right under the surface of the more obvious perks here, and that's standardization. So right now we have experienced personnel reviewing various medical images for meaning, which means that personal and experience bias inevitably creeps in. Plus, we all have off days, we have times when we're in a hurry, etc. It's essentially, there's a human element here, right? Now, with AI evaluation comes a level of standardization that was previously impossible. So if desired, AI systems can be centralized so that the entire AI system is learning from every image that has ever passed through it. And the model will continually improve and evolve over time, which means the model may not always produce the same result for the same image as time goes on. However, theoretically, wherever you use the AI system, it should be able to analyze the image the same way and provide the same result based on all data currently available. If we had 10 humans providing 10 answers at 10 different clinics, we would probably come up with a little map of answers because they would differ based on individuality of the human brain. Versus if we run the same image through the same AI program with the same settings at 10 different clinics, that should lead to the same answer every time. Thus, there is this potential for us to standardize our lab analysis processes in a completely unprecedented way that we just couldn't do before without AI. All right, now it's time for number 5. So while it kept a rather low profile at the conference, Illumina's NovaSeq X is an incredible advancement in our ability to perform whole genome sequencing quickly and affordably. This is Illumina's most powerful sequencer yet, Plus, it's paired with the Dragon Bio IT platform, which, as stated on the company's website, provides award-winning accuracy for rapid, easy to use, and efficient genomic data analysis. So while the cost and time to sequence a whole genome depends on a few different factors, I've been told that you can sequence a whole genome for as low as $200 in around 13 hours. Do you guys remember when it took $1 billion and multiple years to do this? So the big takeaway here is that whole genome sequencing is becoming, 1, affordable for the general population, and 2, probably coming into a range where insurance companies will increasingly provide coverage, though we're still not quite there yet. Another exciting area at the conference was AI-driven multiomics software. And multiomics is the idea of combining various data sets, so genome, microbiome, proteome data, etc., to elucidate deeper insights. GeneGenie DX is working on a software that ingests annotated full transcriptome data, then identifies biomarkers that are common across various disease states. So, for example, you could load a data set that included data for 2 cohorts, a healthy cohort and a cohort that has breast cancer. Then the AI-based software can analyze the data, assess it in light of all the published literature with an integrated large language model, and then tell you which biomarkers are best to identify and leverage in the treatment of the breast cancer for that specific patient based on, lifestyle and environmental exposure biomarkers to genetic biomarkers. So finding new clinically relevant biomarkers is like finding a needle in a haystack. It's hard to do. And the cool thing is that AI software helps us pinpoint those underlying biochemical mechanisms for various diseases. And this will be honestly the game changer for preventing and potentially even eradicating diseases that even up to this day, we still struggle to understand. So in my opinion, it's technology like this that's going to finally help us get a grasp on beating cancer and neurodegenerative diseases like Alzheimer's. Now, I did want to give a shout out to the continually evolving drone industry as disruptive technology number 7. Drones are used to transfer medical supplies, which is especially impactful in more remote and hard to reach areas. While this technology is not necessarily new, drones have been around for quite some time now. It is becoming more and more disruptive as regulations and processes catch up to our technical capabilities. So Zipline is one of the more established companies, but there are a number of companies operating across various geographic areas, and they have different drone designs. Zipline actually recently announced a home delivery platform that is ultra precise, nearly inaudible, and up to 7 times faster than traditional delivery via car. If you're wondering how this is going to work from a regulatory perspective, that is indeed going to be, a big hurdle for this industry, but it is continuing to push forward and evolve. All right. And the last one, number 8, is related to sexual health. So there are a number of companies creating quick point-of-care devices to diagnose STDs and STIs. For example, Binks has come up with a rapid molecular FDA-cleared point-of-care testing device that detects chlamydia and gonorrhea in 30 minutes. So while this is a relatively obvious step forward, I do look forward to the day when STD testing is so quick and affordable that people can easily test themselves before or after any sexual encounter and get reliable results within minutes. I think this would go a long way in reducing the spread of STDs. And though perhaps not the sexiest thing, imagine if you could do a quick test prior to sex with a new partner just to confirm you are both clean and provide that peace of mind. I think that would really be incredible. And we're reaching the point where that may soon become a reality. And that's a wrap. There were so many exciting innovations at the conference, but these were the ones that caught my attention the most that I wanted to share with anyone who watches this. Of course, a huge thank you to all the amazing people I met who took the time to answer my hot mess of questions. I walked into the conference having very little understanding of how a lab works on the back end and the complex B2B environment that powers it all. But I walked out feeling like I had a solid understanding of the key players and the future of this space. And In a one-sentence summary, let me welcome the automated, intelligent lab of the future that comes to you and provides AI-based diagnoses and treatment recommendations on the spot. So if you made it this far, thank you for watching, and reach out if you have any questions or comments. I would love to hear what other people have to say because I am not an expert in this space. I'm just really curious and excited for the future of the laboratory.